Hello everyone, and welcome back to a new series of Gamemaker tutorials in which I will show you how to make a beat 'em up game. Very similar to the style of Castle Crashers or to the one I'm making currently if you've seen that post on my YouTube channel. It's a simple untitled game about Karim beating up a bunch of thieves. So, in this tutorial, we're going to learn how to move around like this, as well as jumping and all that good stuff. And we're also going to we're going to make sure that the animations are controlled through a state machine. So you'll have punching, you'll have ducking, and attacking from there. You can jump and you can kick, all kinds of good stuff. So yeah, and if you want to use these sprites, I'll put a link in the description where you can download them yourself. Alright, perfect. Let's go ahead and start this. So, right here in front of us, we have a brand new project that we're going to be doing all of this in. So let me kind of show you what we're going to have. So here in the room, I've created basically this very simple background where it kind of has this like ground and also has this like sky or whatever. We have our player object. So our player, these are some of the sprites you can download. These are all just prototype sprites, very simple stuff. And these are all different states that the player can be in. So I don't know what kind of beat 'em up your game is going to be, but this little pack of sprites should generally cover a lot of the options that you'll probably see in a beat 'em up game. So that's what this is here. This is the sprite for the ground background that I have back in my room. So that's fine like that. This global setup script you won't need to worry about. So all we're really going to be doing is we're going to be creating one new object, and we're going to be calling it obj_player. So create object obj_player. So that's the object, the only object we're going to be needing. What you can do is here, set the sprite to proto idle. That'll be what it looks like. Then we go to our room and we just click and drag our obj player into the room on an instances layer. So as you can see, just like that. So now what we're going to do is we're going to go into how to code this thing. So basically the idea is in these beat 'em up games, they have a lot of animations, and we need to make sure that we can easily control the animations of our objects. So the way we're going to do that is by setting up something called a state machine, which essentially how it'll work is when the player is in the running state, no code from the punching state is running in the other state. So like if the player is idling, then they're just running code in their idling state. If the player is jumping, then they're just running code in their jumping state. It keeps everything kind of sectioned off so it's easier to use. So in order to set that up, we need to set up a few sprites here. So the first thing that we're going to do is we're going to set up an enum. An enum is basically a way, well, I won't get into it, but basically these are all just different numbers. We've just given the numbers fancy names so we know what they are. So states, there will be an idle state for when the player is idling. Where is it? It's right here. There will be a running state for when the player is running. That's this one here. Duck enter, so that when the player enters the duck state, when the player is ducking, and when the player exits the duck state. We have a flying kick. We have a low kick for when the player is ducking and attacking at the same time. We have a state for when the player is in the air. And we have a punch state. So these are all the states, and then to set off the first state that the player has, we're going to set current state is equal to states.idle. And then this here, we're going to use move and collide. And so this is technically what we need for the move and collide script. You have to put in an object or a tile set to collide with. I created this object called obj underscore solid. Here it is here. As you can see, there's no code, there's nothing ticked, there's no sprite. We aren't actually going to put this in the room. I'm just using it for the move and collide script later. Now you can have walls and stuff like that, and so in that case you would give obj underscore solid a sprite, and then it would be a wall for your player to like run into and all that good stuff. But for now, I'm just going to set it to this object that does literally nothing and isn't in our room. Okay, this next piece is what's called a struct. So a struct is basically a way to store data with a name. So as you can see, my sprites, when we type this in, my sprites dot duck enter. So this right here is going to be equal to this right here. And so why do we do that? Well, the simple reason is we're going to set up animations for a little bit. And in case you want to change the animations of your object at any point, this is just a really easy way for you to do so, because it stores everything in a very easy to read format. So that's lovely. Animation finish is equal to false. I'm going to explain what this does. All we have to do is set this up right here. Anim underscore y is equal to 0. Anim underscore x is equal to 0. I'm going to explain those as well. My friction is equal to 1.5. This is kind of just to let the player like slide a bit once they've stopped moving. And so that's what we have there. Then we're going to set up some stuff you might have seen in other tutorials. So HSP, VSP, this is going to be our horizontal and vertical speed. I have VSP there twice, that's my bad. ZSP, I'm going to explain what that is, but basically what we need to do is when we jump, we need to go up, but we can't go up the same way that we go up when we press the up button. You know what I mean? So this is just like a visual animation effect. My Z, I'll explain what that is in a second. The speed, this is the speed the player is going to be moving around in. So you can set that to whatever number you want. And then jump speed is equal to 10. So that's how fast our player is going to go up whenever they press the jump button. All right. So one thing I really, really like about state machines is that they work based on animation. But part of the problem with Gamemaker is that it can be kind of hard to figure out when an animation has ended. So what I do for that is with this animation finished variable, I set that to false. And then we're going to create a new event called the animation end. So as you can see, animation underscore finish is true. So we realize that whatever sprite index we have, whatever sprite we're currently set to, if the animation for that sprite ends, this event will tell us, and it'll set this variable to true. So that's really, really useful, because now that allows us to come into the step and use this variable to define certain things. And then the last event we're going to be playing around with after the step event is this draw event. So we're not going to worry about that part. I'll explain in more detail soon. But for now, in the draw event, just put draw underscore self. And then we'll get into what this stuff is in a second. So now let's go into step. And let's set up controls. So as you can see, here we have the horizontal movement. Here we have the vertical movement. So if you played Castle Crashers or most other beat 'em ups, they have this system of movement called 2.5D, where it's kind of 2D looking, but the player is still able to move as if they're in a top-down game. So they're able to move up, down, left, right, etc. We're going to set up a button for jumping. So this is keyboard underscore check underscore pressed. That pressed is important. Ord X. This X is capitalized. Remember when you're using this ord keyword, the letters inside need to be capitalized. We're going to set up duck the same way. That's going to be on our Z key. Attack the same way. That's going to be set up on the C key and all that good stuff. These two variables we don't need right now. That's my bad. this is a pretty simple system. Like, as long as these keys are intact, you can change these controls around to whatever you see fit. So if you want to go back and change it later, feel free. All right, we're going to set up a grav variable. So the gravity speed is going to be underscore grav. And then what we're going to do is, remember that ZSP? Well, that is our speed on the z-axis. So the z-axis is like up and down. Because we're already using the x and y-axis, which are built into Gamemaker. But we're going to make a pretend z-axis so it looks like our player is jumping. So basically, we're always adding 0.5 to ZSP. And then we're always adding ZSP to my underscore z. And then my underscore z, we're making sure that it's never lower than 0. Because when the z is 0, the player is on the ground. And then finally, what we're going to do is we're going to set anim underscore y is equal to my underscore z. So this variable, we don't have it set up yet. It's going to set up here in draw. But when this variable is set, this will control basically how up or down our sprite looks. The next thing we're going to do is make sure that the player is facing the right direction. So basically what we're going to check is if this horizontal value, this is going to either return 1, -1, or 0. So basically, as long as it's not 0, we're going to set the x scale of our sprite to underscore horiz. That will allow us to face the direction we're moving in, basically. All right, so now we're getting into the meat of our state machine. So this is a switch statement. And basically, this is going to check one value, one variable. And if the variable is any of these values that we have set in here, then it's going to set it to that. Oh wait, there's one more thing down here. Okay, so these two things are important. This move and collide, HSP, VSP, solid list. This is what's actually going to move our object. So make sure you have that beneath your state machine. So we're going to go into this in a second, but beneath your state machine, you have to have move and collide, this, and then animation finish. Basically, what this does is every time our animation ends, it gets set to true. Then any single state here, if any of these states I want set up so that they're dependent on when the animation actually ends, then they can use this variable while it's true, and then after the whole event has finished, we're going to set animation underscore finish to false. So then we know that the animation has no longer finished and it's time to just go back to things as normal. So these two lines of code absolutely have to be beneath our switch statement. Otherwise, the code will probably break and you'll see weird things happen. So now that that's finally talked about, let's go into this massive switch statement. So make sure to put brackets, switch, cur state, and then case state idle. So if cur state is equal to states.idle, this is what we're going to do. First, we're going to set the sprite index to mysprites.idle. So if you remember, that's the struct we set up. So it'll set up to this sprite. Perfect. Since we're idling, we know that the player isn't moving. So basically what we're going to do is we're going to bring HSP and VSP down gradually by dividing them by my friction. And if they're over 1, it's going to do this. If not, we're just going to set the HSP and VSP to 0. So this is just friction. Now, this block here is what tells us that we need to leave the state. So there's a few if statements here. So first we're going to check if underscore horiz is not equal to 0, or if underscore vert is not equal to 0, then the current state is equal to states.running. So basically what that's going to do is if the player is pushing the left or right key or the up and down key or both of them at the same time, then we're going to go to the running state. If the player has pushed the duck button, then we're going to enter the duck state. And this line of code right here is important. The duck state, ends once an animation ends. So that not only means that we're going to use animation underscore finished, but we're going to want to make sure that the animation is reset before we go to that state. So because of that, we have to set the animation back to the first frame of the animation. So this image underscore index, it controls what frame of animation we're on, and we're just going to set it to 0 to make sure that this animation underscore finished thing works as intended. So we're also going to check if the player has pushed the attack button. If so, go to the punch state, reset animation. Now, this next part says underscore jump. If we've pressed the jump button and our z, our myz variable is equal to 0. So basically what this means is that we're on the floor. Then our current state is going to be states in air. And then we're going to set our ZSP to negative jump speed. If you've made a platformer before, this piece of code will probably look pretty familiar to you. If not, basically what it does is it sets the direction that we're going, or our momentum on the z-axis, to negative jump speed, which will make us go up. In GameMaker, negative is up. All right, so let's look at the running state. So when we're in the running state, what do we have to do? Well, we have to set our sprite index to mysprites.run. We have to move. So basically what we're going to do is, if the horizontal value is not equal to 0, then the horizontal speed is equal to the horizontal value, which is 1 or negative 1, times speed. So speed is 20. Yeah, 20. So we're going to move left or right by 20 pixels. Otherwise, we're just going to bring HSP towards 0. Same deal with a vertical. So vertical is not equal to 0. Blah, 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 blah. VSB is equal to underscore vert. What I did here is I've halved speed. Basically what you see in Castle Crashers and other games like that is that the player moves slower on the y-axis than they do on the x-axis, because you're technically viewing the ground from an angle. So this kind of supports that illusion that you're viewing the ground from an angle. You can just put speed if you don't want that, or you can make up your own speed variable if you want to play with this value more. But for what I've done, I've just done speed divided by 2. So the player just moves slightly slower in the y direction. If not, we're going to apply friction to our vertical speed. All right, the leave state block. Basically, the first thing we're going to need to check, if horizontal is equal to 0 and vertical is equal to 0, this right here is an AND, then our current state is equal to states.idle. So go back to the idle state is what that's saying. Duck, this is basically the same thing that we had above in the idle state. So duck enter, punch, blah, 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 jump, so we can jump from here, and it's basically the same thing from the idle state. So far, so good. Now, let's move on to our punch state. So, this one's going to be working a little bit different. So, what we're going to do is sprite index is equal to mysprites.punch. I have it set up so that the player stops moving when they punch. If you want the player to move and punch, that is a little bit more technical. But for the purposes of this tutorial, we're just going to do this. We're also going to make sure that we're on the floor. So our ZSP and our myZ are both set to 0. Then what we're going to do is, if animation finished, we go back to the idle state. And then this here, I think I put this here to fix a bug. I think there was a bug where the punch state could go straight to the idle state. It might not matter, I'm not sure. But anyway, you can try it just with this line of code. I honestly don't think this line of code does anything. But yeah, that's the punch state. So as you can see, you can't go from a lot of different states to, you can go from a lot of different states to the punch state, but you can't go from the punch state to a lot of different states. It just goes right back to idle. And that's fine because the idle is kind of like the hub of where all the states branch off from. So as you can see, there's very little options here for where to go when you leave the state. But that's just fine because we don't really need to. We want the player to stay in this animation until the animation is finished. All right, in air. Basically what we're going to do here is we're going to check our ZSP. And if it's less than 0, then the player is moving up. So we're going to set the sprite index to in air up. Otherwise, we're going to set the sprite index to in air down. Easy as that. And then if my underscore z is more than 0, more than or equal to 0, basically what this means is that we are on the floor again. And if so, we're just going to go to the idle state. And we're going to zero out these two values. If we're attacking and in the air, what we're going to do is we're going to the flying kick state. So this is actually pretty cool because with this state machine, if you're in another state, you can go to different states based on the same button. So that's another advantage of having these state machines. It just keeps everything so nice and so clean, and you don't have to worry about certain things. So let's check out the flying kick state. Flying kick state, it basically just works the same as the last state, except we're going to set the sprite index to flying kick, which is the f underscore kick. We leave the state in exactly the same way we do for the in air state. That's just fun. Next, the duck underscore enter. So basically what this does is, the way I have it set up, let's take a look at the sprites. So as you can see here, basically the player starts standing up and they crouch down and then they're in the duck state. So how it works is we set the sprite to the duck underscore enter state. We obviously stop the player because we want them to stop moving. And then if animation underscore finished, so if we've detected that the animation is finished, then we go to the duck state. And then we have this right here, which I'm pretty sure I put there to fix a bug. I'm not sure if removing it will be good. Alright, low kick. Actually, let's go over the duck state first. So, after the duck enter state, we are in the duck state. Sprite index is equal to mysprites.duck. So this is just a simpler version where the player can stay in this animation forever. In the duck state, you can't move around in my game. In your game, you can totally have something different here. You can make new states or whatever. But for this, we are just going to make sure that the player stops the same way that they do in the idle state. And then how we leave the state? Well, if we attack, you can go to the low kick state. That one is animation dependent, so we're going to set our animation frame to the first frame of animation. If we have released the duck button, then we're going to go to the duck underscore exit state, which is where the player stands up from their state. And that one's dependent on animation, so we need to reset the frame for that one. Alright, low kick. So if my sprites, so we're going to set my sprite to low kick. We're going to decrease the speed slower. This one I've divided by 2, so that would make low kick slower. I don't really think we have to do that, but whatever. This is code I'm working on for a game. So there's some little things I played around with, and most of them don't do much because like the player isn't going to come into this state with a lot of horizontal and vertical speed. So it won't really change that much. But I suppose they could, so this should probably just be, oh, whoops. Should probably just be my friction alone. There we go. All right, leave the state. So basically, we're going to check if animation finished, and if it is, just go to the duck state. And also reset our image index. We don't technically need to because we're just going to the duck state, but I did anyway. It won't make that big of a difference. All right, duck underscore exit. So we're going to check if the animation is done, and if so, leave the state. Basic stuff. We also are decreasing HSP and VSP here, so that's just fine. All right, good to go. And then, as I said before, HSP, VSP, solid underscore list, which will tell us what kind of objects we will collide with. None of these objects are going to be in our room for now, so the player's not going to collide with anything, but that's all right. And animation finished, false. So that is our step event. That should have everything we need. Oh yeah, I don't think we went over flying kick. So flying kick, sprite index is equal to flying kick. Oh yeah, we did. All right, cool. So that should be everything in our state machine. Really very simple, just a lovely way of cutting down the code that is currently running in each of these spaces. So that's very simple to both see and debug and to add stuff to. So let's go ahead and run our game. All right, perfect. So as you should be able to see here, if we press the arrow keys, our player moves around. They turn left, they turn right, they animate correctly, and all that good stuff. They should be able to punch if you hit the C button. They should be able to duck if you press Z. And if you press Z wall, you're crouched. If you push C, then they attack like that. That's really cool. Now, if we hit X, you should see something happen, but the player isn't going to move up and down. So, what is going on here? Well, let me paint it this way. You see, X and Y are these very important variables. And so, when we move the player up and down, I don't want to physically move it up on the y-axis. I want it to look like the player is moving upward on the y-axis, but the player has a hitbox and the player has, collisions and all these kinds of things. And if we physically move the player up when they jump, we could have issues with that. Basically, I want to keep the hitbox and the player's X and Y right here so that when the player falls back down, they are back where they jumped from. But I don't really want to change their hitbox or their X and Y position. So how are we going to do that? Well, the answer is actually really quite simple. Basically, let's go to draw. So what this does, this right here, expanded out, is this function, technically. Basically, what draw self does is it draws our sprite index. Hang on, wait. I need to see some of these. So our sprite index at our image underscore index, at our X, at our Y, at our X scale, at our Y scale, at our image angle, at our image blend, and at our image underscore alpha. So what draw self does under the hood is it's literally just this. All of these variables here are basically our built-in object variables that keep the player doing, keep the player in the right spot. So if you don't have a draw event, or if draw self is in your draw event, basically Gamemaker is running this, right? Simple as that. And if you were to remove draw self, like we will here in a little bit, and just run this, you're going to see the exact same thing when you run the game again. Easy as that. However, this presents an interesting thing because if we did something like minus 100 here, that would still draw our sprite all correctly, but it would draw the sprite 100 pixels up in the air. So what that means for us is with this, we can give the illusion that the player is 100 pixels up in the air. However, their X and Y would still be like right here. Like the player would be up 100 pixels in the air, but their X and Y would still be right here. Their hitbox would still be right here. Their sprite would just be like where they're visually represented on screen would just be in a different position. So that is what we are going to do. We are actually going to set up our z value with y. So when we press the button to jump, it only looks like we're jumping when in reality we technically aren't. So what I'm going to do is I'm going to delete all of that because we don't need it. And then I'm going to add this code. So we're going to set the draw set color to white. We're going to set the draw set alpha to 1. And then we're going to draw our sprite index, our image x scale, our image y scale, our image angle, our blend, our image alpha. You might be a little bit confused, but this is the same function we had up there. All I did was I hit enter between all the values so that you can see them clearer. So this is the same draw sprite underscore ext function. However, what we're doing is we put an anim underscore x here, which is our variable that we set up right here, our anim x and anim y. And we're also going to set up anim underscore y here, as you can see. Now, if you remember, we already have anim underscore y plugged in back here to be our z value. And this z value basically controls how high up our player is. So if we go ahead and run the game again, we're going to see something pretty cool. All right, perfect. So now if we hit the jump button, yay, the player jumps. See, just like that. Now, it's important to know, like, this isn't real z-axis stuff. Like, this is all animation. Like I said before, the hitbox is still here. The X position is still here. But it just allows us to get a really simple jump effect that works and that looks good. And of course, if you can still use this for checking if the player, like gets hurt by something or whatever. So like, for example, if you don't want a certain attack to connect with the player when they're jumping, all you have to do is check if the player is in air, which is what they are right now, if their state is equal to the in air state. And if so, just like don't hurt the player. And if their state is not the in-air state, go ahead and hurt the player. All kinds of things like that. So it still has a lot of uses. Just don't expect this to turn into like a 3D platformer kind of thing. You know what I'm saying? But that's all fine and dandy. That works great. The next thing we're going to add is we're going to draw a shadow on the floor just so that it's easier to see. And this will make the point I was talking about earlier really obvious. So as you can see, what we're going to do is we're going to set the draw color to black. We're going to set the alpha to 0.5. We're going to set the ellipse width to 50, the ellipse height to 25 in these temporary variables. And then what we're going to do is we're going to draw the ellipse. So x minus ellipse width, x plus ellipse width, b box bottom, that is the bottom of the sprite, minus ellipse h, b box bottom plus ellipse h. And we're going to set it to false so that the ellipse is filled in. And then we're just going to reset the color and alpha. I guess we don't have to have two of those. So that's all that we need. So this will draw a shadow. And now if we run the game again. All right, perfect. So now you can see a little shadow. And as we jump, even though it looks like our Y position is changing, even though that would necessarily change our B box bottom, the shadow stays roughly in the same position it was. So that's how we know that this up and down motion, this in-air motion, is all just an illusion. And that's just fine. That works perfectly. So, thank you so much for watching. That is all that we have for today. Um, I'm hoping to do some more of these if this video is helpful for you. So if it was helpful for you, feel free to leave a like and a comment. And also, if you'd like to be notified when the next video arrives, go ahead and hit the subscribe button. Thank you so much for watching, and have a lovely evening.